In this video, we dive into the fascinating topic of the ancestral DNA of the Israelites, which links back to ancient Middle Eastern populations and shares a Semitic origin. This is the second part of our series on the genetics of the ancient Israelites, where we'll continue to explore this intriguing history. Today, we will also investigate other Jewish communities that, like the Israelites, carry this same Semitic lineage in their genetic roots. Through extensive genetic studies, we will reveal not only the origins of the Israelites, but also some of the most well-known Jewish groups today, uncovering ancient secrets hidden in their DNA. In this study, we'll explore how these genetic links connect modern-day Israelites with biblical patriarchs such as Abraham. By doing so, we'll uncover intriguing mysteries surrounding the migrations and intermixing that have shaped the identity of this people throughout the millennia. The genetics of the ancient Israelites, including the DNA associated with figures like Abraham, are a key aspect of population genetics, an exciting field that plays a crucial role in understanding the migratory patterns of the Jewish people over time. These studies are supported by a variety of other academic fields, including history, linguistics, archaeology, and even paleontology. Together, these disciplines work hand in hand to deeply explore the diverse origins of different Jewish groups, often referred to as Jewish ethnic divisions. One of the most significant mysteries that researchers aim to solve is whether all Jewish branches share a common genetic heritage. This raises the question of whether there is a shared Semitic ancestor such as Abraham who links all of these populations together. To explore these connections, several studies have utilized three primary types of genealogical DNA tests: autosomal DNA at DNA, mitochondrial DNA, mtDNA, and Y chromosome, yDNA. Autosomal DNA tests, for instance, focus on analyzing an individual's entire genetic makeup, helping to identify populations that make up what are known as genetic isolates among Jewish groups. Mitochondrial DNA, mtDNA, focuses on the genetic material passed down from mother to daughter, allowing researchers to trace female lineages across generations. Meanwhile, yDNA tracks the Y chromosome, which is inherited exclusively from father to son, making it crucial for mapping male lineages. These studies reveal not only the remarkable genetic continuity of the Jewish people throughout the centuries, but also the various mixtures, migrations, and interactions that have shaped their identity over time. They provide a window into the past, linking the present to ancient Semitic DNA. One of the most frequently cited examples of ancient Israelite DNA comes from a study that analyzed genetic material recovered from the remains of Israelites who lived during the First Temple period. These DNA samples were extracted from bones found at the archaeological site of Kiryat Yim. Professor Israel Feldstein led the study in which the remains of two individuals, a man and a woman, were analyzed. The research revealed that the man belonged to the J2Y DNA haplogroup, while the mitochondrial haplogroups identified in the woman were T1 and H87. It's essential to highlight that both the DNA of Arabs and that of ancient and modern Jews predominantly share a genetic component known as Neolithic Levant, which I refer to as the predominant fraction of ancient Semitic DNA. This genetic marker is widely found among both Arabs, especially the Arab populations, and Jews. All peoples of ethnic and racial origin from the Middle East, both past and present, have as a major part of their ancestry a genetic component known as Levant Neolithic Farmer. This intriguing component is largely derived from two ancient genetic groups: the Natufians, who contributed around 33%, and the Neolithic farmers of Anatolia, who accounted for approximately 35%. Together, these two groups formed the Levant Neolithic farmer component, which serves as the foundation of the ancestry of Semitic peoples, at least in their predominant genetic fraction. Now let's talk about a well-known Jewish group that I didn't cover in detail in the previous video, the Sephardic Jews. This group is one of the most renowned, particularly in Latin America. Many Sephardic Jews migrated to countries such as Brazil, Mexico, Argentina, Venezuela, and Colombia, both during the colonial era and in more recent waves of migration. Additionally, Sephardic immigration to the United States also took place in several phases, with a significant presence in cities like New York and Miami, primarily of people coming from Latin America and the Middle East. Let's dive into some details about the DNA of Sephardic Jews, starting with the genetic percentages of ancient Israeli DNA, focusing first on the paternal lineage, or Y DNA. This will help everyone gain a clearer understanding of the paternal genetics of this group. A particularly important study was led by geneticist Harry Ostra from the New York University School of Medicine, NYU. Ostra and his team conducted extensive research to map the DNA of various Jewish populations, including Sephardic and Ashkenazi Jews. His research helped confirm that Sephardic Jews share a common genetic heritage with other Jewish populations, with origins tracing back to the Middle East. The study found that Jews living in Morocco and Algeria had a higher degree of European admixture in their genetics compared to Jews living in Tunisia and Libya. This is likely due to the large number of Sephardic Jews expelled from the Iberian Peninsula after 1492 and 1497, who then settled in Morocco and Algeria. Despite this, all Sephardic Jewish communities in North Africa showed a high level of endogamy. A study conducted by Inés Nogaro and her team in July 2009 on the Jews of northeast Portugal in the Trans-Ossau region revealed that their paternal lineages consisted of 35.2% typical European lineages, specifically R 31.7% and I 3.5%. Meanwhile, 64.8% of their paternal lineages were more characteristic of the Middle East, including E1b 18.7%, G 3.5%, J 36.8%, and T 15.8%. Although there was a significant portion of 35.2% European heritage through the paternal line, Sephardic Jews showed a predominant 64.8% genetic connection to the Middle East. This indicates that, paternally, Sephardic Jews are more closely related to other Jewish populations than to non-Jewish Portuguese individuals. In terms of mitochondrial DNA, mtDNA, the analysis of Sephardic populations, particularly from Morocco, Tunisia, Libya, as well as Portugal and the broader Iberian Peninsula, was the focus of a more in-depth study in 2008. This study revealed significant genetic similarities between Ashkenazi and Sephardic Jews, especially concerning mitochondrial DNA of European origin. Some proposed genetic percentages include a 27% European contribution among Moroccan Jews, 43% among Tunisian Jews, and 39.8% among Libyan Jews. Additionally, it has been suggested that the 39.8% mitochondrial DNA of Libyan Jews could be traced back to a woman carrying the X2E1A1 lineage. Now, speaking about genetic data concerning ancient Israeli DNA, Sephardic Jews display around 30% to 43% of ancient Israeli DNA in their genome, which is very similar to what is observed in their Ashkenazi Jewish counterparts, who also have similar levels. The Iberian European heritage makes up 57% of the DNA of Sephardic Jews, closely aligning with the genetic composition of Ashkenazi Jews. On the other hand, when we turn our attention to the Jews of Ethiopia, known as Beta Israel or simply Black Jews, It is worth noting that several genetic studies have been conducted on this population. From a genetic perspective, despite their claims of direct descent from ancient Israelites, it is crucial to analyze their DNA through scientific research to confirm whether they indeed possess ancient Jewish ancestry, particularly from the tribe of Dan, as some have claimed. Let's begin by examining uniparental lineages. Genealogical DNA tests provide the means to investigate both paternal and maternal ancestry. According to studies conducted in 2002, haplogroup A is the most common paternal lineage among Ethiopian Jews, being carried by approximately 41% of Beta Israel. This haplogroup is primarily associated with Nilo-Saharan-speaking populations and also with Kisan peoples. However, the branches carried by Ethiopian Jews are predominantly of the AY23865 variety, which emerged millennia ago in the Ethiopian highlands. Additionally, around 18% of Ethiopian Jews have lineages from haplogroup EP2 XM35 XM2. In Ethiopia, most of these lineages are part of EM329, which has been identified in ancient DNA extracted from an Ethiopian fossil dating back approximately 4,500 years. These haplotypes are commonly found in southwest Ethiopia, particularly among Omotic-speaking populations. The remaining Beta Israel individuals primarily belong to haplogroups related to EM35 and JM267, which are typically associated with Cushitic-speaking populations in Northeast Africa. More detailed analyses show that haplogroup E-M35, found among Ethiopian Jews, primarily originates from the Horn of Africa rather than from a Levantine origin in the Middle East. A mitochondrial DNA study conducted in 2011, which focused on maternal ancestry from 41 Beta Israel individuals, revealed that 51.2% of them belonged to the macro haplogroup L, which is typically found in Africa. The remaining lineages were of Eurasian origin, including 22% R0, 19.5% M1, 5% W, and 2.5% U. However, no identical haplotype was found to be shared among Jewish, Arab, and Ethiopian populations, indicating very limited gene flow between these groups and suggesting the possibility of distinct maternal ancestry histories. The maternal ancestral profile of Beta Israel is more closely aligned with populations from the Ethiopian highlands. Regarding autosomal ancestry, the autosomal DNA of Ethiopian Jews was analyzed in a comprehensive study conducted in 2009, which examined the genetic affiliations of various African populations. Based on clustering analysis, Beta Israel grouped most closely with other Cushitic-speaking populations from Ethiopia. Beta Israel showed greater genetic proximity to populations from the Horn of Africa than to any other Jewish populations, including Yemenite Jews. According to a 2020 study, the DNA of Ethiopian Jews is primarily of Eastern African origin, rather than Semitic. However, about 20% of their genetic composition does indeed have Semitic origins from the Middle East, showing similarities to modern Jewish and Arab populations. Although the presence of Jewish DNA is quite limited among Ethiopian Jews, it is still detected at levels of around 10% mixed with Arab DNA, as revealed by the studies. This results in approximately 20% Semitic DNA coming from both Arabs and Jews. In comparison, the Eastern African genetic origin of Beta Israel is much more prominent, accounting for 80% of their genetic composition. I want to thank everyone who has watched the video so far. A big hug to each of you. If you're interested, I can create a third part focused on ancient Israeli genetics. Feel free to leave your comments, especially if you already knew more about the genetics of Sephardic Jews. May God bless you all, and see you soon.